This is Chapter 2, Section 3, Formulas and Problem Solving. And we're going to look at the first objective, which is solving a formula for a specific variable. And let's just look at this. So here's a list of formulas that are commonly used. The first one relates interest, which is I, with the principal you pay, the interest rate, and the time. Over here is its English expression, simple interest is equal to principal times rate times time. Many times we will use variables that start with the first letter of the word of the object denoted. That's certainly the case here. I is equal to PRT. This formula, sometimes R is lowercase, T is lowercase, and even P is lowercase. It doesn't really matter. The next one is the area of a rectangle. The area of a rectangle is just its length times its width. This one you absolutely need to be aware of if you're not aware of already. Eventually you own a house and you'll want to repaint or maybe buy a rug for a floor or calculate something that requires that you know how many square feet are to be covered. And that area many times is rectangular. So you find that area by measuring in feet its length times its width, and that gets you its square feet. Distance is equal to rate times time. Here that rate is the rate of movement. Another word for that is speed. So here is the English part of it. C is equal to 2 pi r. C is the circumference of a circle. And just in case you are unfamiliar with that, if we have a circle, like this, and what I'll do here is try to draw a radius. So that's not the radius, that's the diameter. So I'm going to say the diameter. So from the center on out, that's going to be the radius. The circumference is the entire length of walking around the edge. So this formula here lets you find that length by multiplying the radius times 2 and then multiplying by the mathematical constant pi. Now pi is an irrational number, so we can never actually write out its exact value because its exact value goes on and on forever without expansion. But pi is approximately equal to 3.14, or if you want to go on, 141592654, and that's as far as I have it memorized. The good thing is we don't care. In this class, you're going to leave pi in its exact form, and the only way we can write it in its exact form is to use a symbol. So if the radius here were 2, then the circumference is equal to 2 times pi times r, which is 2 times pi times 2, which is 4 pi. And that's the form we want it in. Just pi. You don't go up and approximate pi. You just write it as it's in its exact form. So the area of a triangle is base times height divided by 2. That makes complete sense. Let's actually derive that. So we know that the area of a rectangle, and here I'm trying to draw a rectangle. And what is the area of a rectangle? It's its length times its width. So suppose I were to split this rectangle in two. The result is going to be a triangle. And it's going to be 1/2 of the length times the width. Well, it turns out that's true for any triangle. In this case, my triangle is a little bit special. You should be a little bit skeptical because my triangle is a right triangle. But it turns out that as soon as you have any triangle, you find its height by taking a vertex and dropping a perpendicular down. So this is a right angle here. We'll denote that by putting that little square there. So that turns out to be the height. And this entire length down here is the base. In which case the area is 1/2 the base times the height. Here we have the volume of a rectangular solid. So let's go back over to my drawing board again. Kind of just give you, I'm not a good illustrator, but let me give you an example here. So I'm just going to draw a square. I'm going to try to duplicate it. Make it a cube. So the volume of the cube, imagine this is an aquarium, and literally the volume would be the area. I'm just curious here. The volume would be the area, that is filled in with water. So that would be the volume. So you've got an aquarium. I guess if I were to extend that line, it wouldn't have done that. So that's the volume. Imagine an aquarium, how much water you need to put in it. So the volume is equal to the length times the width times the height. Over here I have, we'll say this is my length. That means this line right here, this will be my width. This line right here, and this will be my height. And that will be the volume. It would be like in cubic inches or cubic feet. And here we have a more complicated formula, and it's compound interest. So A is equal to P. So A stands for your compound interest, how much money you get after T years, compounded in times at rate T. So we'll actually look at an easy one of these. We'll actually derive it, and we won't derive it, but we'll almost derive it in college algebra next semester for hopefully many of you. But it's just A is equal to P times, in parentheses, 1 plus R divided by N. So this is the base, what's in parentheses, raised to the exponent N times T. N is the number of times compounded per year, and T is the total time in years. So you should be familiar with many of these already. The ones I'm suggesting you probably are not familiar with might be the interest in the compound interest formula, and you're probably not familiar with D is equal to RT, distance is equal to RT, but you do know it all the time because you know speed is measured in miles per hour, and speed there is our rate, and from that we can actually derive this pretty easy. So let's go ahead and work on example 1. So we're going to be solving, this always seems, I think students, okay, I'm going to tell you right now, don't make this overly hard. Students always have problems with this, or a large percentage of them, and it has to be because they're making it too difficult. Another possibility is you don't have, there is a possibility that the foundations are not there, but let's see what we can't do to take care of that. So here we have a formula, and it is volume is equal to length times width times height. And we want to solve for H. So I'm going to give you an example of this. I'm going to give V an actual value. Now I'm going to give L a value of 2 and W a value of 2, and H is going to be my unknown. So how would you solve for, so H is standing for our X here. It's our unknown. So how would you solve for H? Well, I already have my variable term over here. You would probably do something like this. 10 is equal to 4H. So my constant terms is on one side and the variable term is on the other. So I know how many 4H's are. So I want to know how much 1H is, and you would divide through by 4, and you would get H is equal to 10/4, which is reduced to 5/2. Now, you're not given any numbers here. You're just given this formula. But you're going to do the exact same thing. So we're going to have volume is equal to length times width times height. So again, this is my unknown H. If you want, you can literally do the problem this way. V is equal to LWX, solve for X, and at the end of the problem, just rewrite instead of X, the variable H. So I already have the variable H isolated on one side. So what I need to do is I need to divide both sides by L and W. Now, LW times H divided by LW just gives me H. And V divided by LW cannot be further simplified because we don't know the values of L and W. But what this does tell you and what this does give you is if you know the volume of something and you know its length and you know its width, then you can calculate its height. Now this is of course the volume of a rectangular solid. This thing, my aquarium thing, I just tried to draw up there. So not too bad, right? So just keep that in mind. These really are not so bad. Here's one. It's almost identical to the other. The only difference is that we're solving for the variable t. Let's actually compare it. We have I is equal to P R T. I'm writing in lowercase, sorry. Before we had volume is equal to length times width times height. And we want to solve for t. Notice there's really nothing to be done if you've already done the other. The only thing I've done is I've swapped the letters. The process is exactly the same. So down here what I'm going to do is I'm going to divide both sides, that's an I, by P and R. And that's going to be equal to P times R times T. But I divided both sides times P times R. But P times R times T divided by P times R is just equal to T. And again, the left-hand side cannot be simplified because I don't know what I is, and I don't know what P is, and I don't know R is. To be really mathematical about it, the only thing I can say is the equation is undefined if either P or R is 0. Why? Because then P times R would be equal to 0, and remember, division by 0 is undefined. So steps for solving an equation for a specific value. I've actually got that ready and written out if I just find it. Here it is. Let's make my window big. So here are the steps. So if needed, and we will need to do this on occasion, clear denominators by multiplying both sides by the LCD. Let me rewrite that over here. The LCD. That again stands for the least common denominator. You may also know it by an equivalent term, LCM. Again, that's the least common, but M means multiple. They both mean exactly the same thing. Tip: if all denominators are variables, just multiply both sides by their product. So if I were to have a formula like R over S is equal to 2 pi times T divided by 4K, what I would want to do in that case, my LCD, would be, here are my denominators, 4 times K times S. So I would multiply both sides by 4KS. 2, when needed, use distribution. For example, A times B plus C is equal to AB plus AC. 5 times 3 plus 1/10 is equal to 5 times 3 plus 5 times 1/10 is equal to 15 plus 1/2. That's what I'm talking about. Use the property of distribution to remove grouping symbols. And the grouping symbols we're talking about here are these parentheses. Then you combine like terms. How do you combine like terms? Well, one of the term, the variable that you're solving for, that's your unknown. So any terms that have your unknown, you put them together, and any other terms, you just treat them like constants. And that's exactly what I say in the next step. Treat the variables you're solving for as an x, and then treat all others as constants, and then solve for the unknowns as normal. So if you've downloaded, maybe I should leave that up for just a little bit. Unfortunately, when I've made the notes for this particular class, I decided when I'm face to face that it's easier, or you retain it more if you write it down. So in my notes there's just a big blank. There's nothing written in here. But if you actually go to our textbook, you will actually probably find those steps written out somewhere. Maybe. Sometimes I will add things that the book doesn't have. And I think that's something I added that the book does not have. That's fine. So that means you'll have to pause the screen and copy them down if you need it. If you need it. So let's actually do a problem where we use these steps. So get some working space here. So we're going to solve, so this is problem 2A actually. We're going to solve 3y minus 2x is equal to 7. And we're going to solve for y. This is a really important problem. You will see many problems identical to this. So what do? We isolate our variable. Our variable term is 3y. So that means I'm going to take this 2x and I'm going to put it on the other side. So my next step is going to be 3y. I'm adding 2x to both sides is equal to 7 plus 2x. And I'm going to kind of give you a hint right here. We know that it doesn't matter if I'm adding two things, any two things, it doesn't matter their order. That's called the commutative property of addition. In other words, 5 plus 1/9 is the same as 1/9 plus 5. So I'm going to rewrite this just to get you in the habit. Since I'm adding 7 plus 2x, and it doesn't matter which order I add them to, I'm going to put the 2x term first, because that's what we'll be doing later on. So I know how many 3y's are. They're this entire sum over here. So I want to know how many 1y is. So I'm going to divide both sides by 3. It's really important that you divide all of the right-hand side by 3. Not just one term and not the other. So 3y divided by 3 gives me y. And then I can either leave it like this, 2x plus 7 over 3, or I can use a familiar property. And we will actually focus on this property again and again. A plus b over c is equal to ac plus bc. That's exactly the rule that we use to figure out how to add fractions. So this is an acceptable way to write it. That's okay. But later on, it's actually going to be a little bit better if we write it this way. 2x divided by 3 plus 7 divided by 3. And it might actually be better for some of you if I even slightly rewrote this term right here. 2x divided by 3 is the same as 2/3 times x, and write it as 2/3 x plus 7/3. You will see that many times in the future. You'll probably see something similar to this one on the exam. So for those of you who've chosen to watch my lectures, that's going to be at least one of the bonuses you get if you can stand all the other foibles I have. 2b. This is the most missed problem on any exam. So we're going to solve for b. At this level anyway. A is equal to 1/2 times a large b plus a small b. So when the case of letters is changed, the large b and the small b stand for two different quantities times h. And wouldn't you know it, they want us to solve for the small b. So the first thing here, notice that the small b is locked inside parentheses. So at some point we will have to use distribution to get it out. So notice, again, by what I just said, this is identical to writing A is equal to B plus B times H, all of it divided by 2. These two expressions are exactly the same. So clearly I have a denominator. So what do? We multiply both sides by that denominator. So I'm going to multiply the left-hand side by 2 and all of the right-hand side by 2. So that's going to give me 2a and b plus small b times h divided by 2 times 2. The 2's cancel. That just gives me my b, large B plus small b times my h. Now here you have two different paths to go. And you can use distribution if you want. But I'm going to do it both ways. In the end, I want to I have to get this small b out of the parentheses. So if I divide both sides by h, that's going to give me 2a divided by h is equal to b plus b. Now you may actually write that in parentheses, and that's okay if you do. But here's the thing. When you write parentheses around an expression like this, and there are no other operations, there's no multiplication going on or addition over here, it may lead you to believe that these two terms are locked inside and corralled inside that. That's not true. Literally, you can just get rid of those parentheses. Nothing has changed. It doesn't change anything. So we're going to get rid of those parentheses. And now it's simple. Remember, I want to get b, small b, lowercase b by itself. And now it's just trivial. I have 2a divided by h. I'm just going to subtract large b from both sides. Minus b is equal to small b. And that's it. That's one answer. Let's start back over here and give you one other way to go. We had 2a divided by, what was it we had? We had, this is where I want to be, 2a is equal to large b plus small b times h. Some of you will want to go the distribution route. Indeed, I kind of suggest you are supposed to do so here. And that means that you're going to want to distribute the h. If you do, it's going to give you the following. 2a is equal to b times h plus small b times h. So again, our variable term is the small b by h, because remember, we're solving for the small b. So I'm going to move this term, large B times h, over. So I'm going to subtract large B times h from both sides. And that gives me my small b times h. And now what do you want to do? You want to isolate or have small b by itself, so you're going to divide both sides by h. Remember, you have to divide the entirety of this by h. So the final answer then would be, if you went that route, 2a minus b, large B times h, divided by h is equal to b. And those are identical. This answer is exactly the same and can be transformed into each other by algebraic. I accept either answer on an exam. On my math lab, it's its own thing. You have to listen to what it yells for, which I think, to be honest with you, is almost unconscionable. What's going on, I'll give you an example. This is my thought, is my math lab, there's all kinds of we call them algebraic engines, programs that can do symbolic manipulation and solve some really, really hard problems in algebra. I mean, I actually have one right there. This is, yeah, here is, I made the computer solve this. This is an iteration of my own research, and you don't want to do that. That's a symbolic engine. And those symbolic engines are great, and they can tell when two problems are equivalent, but they are proprietary, or if they're open source, you can't be used for commercial sources. In Pearson, I don't think uses those, or they can't use those symbolic ancients, and they've not developed their own. So my math lab is really picky about how they want things entered. So I think they've got enough money by now that they should be able to take care of that and get a symbolic engine. And maybe some of their other calculus-based ones do. I don't know. Or some of the new ones do. So this is equal to A is equal to, this is our formula, P plus P R T. And we're going to solve for R. So R is our unknown term. So what do we do? What do we do? What do we do? Well, we want to isolate this term right here. Notice that in math, just like in multiplication, just like in addition, we have A plus B is equal to B plus A. We also have A times B is equal to B times A. In other words, the order in which you add numbers doesn't matter. The order in which you multiply numbers doesn't matter. So if you wanted to, you could rewrite this P times T times R. Because it doesn't matter, this is P times R times T, which is the same as P times T times R. And sometimes it's just kind of nice to have our variable to be the last one in the line, right? At any rate, I'm going to go ahead and move this P term over so I can isolate the term that has our variable. Now if you want, you can literally, if you have colored pencils and you like to work with colored pencils, you can always write your variable term in a different color if needed. And now it makes it really, really clear what you need to do. I have my constants over here and my variable term over here, so I know how many P times T R's we have, but I want to know how many single R's we have. So we just divide both sides by P times T. And don't leave it in that form. Write it out. That's A minus P over P times T is equal to P times T times R divided by P times T just leaves my R. Okay. Okay, I'm going to redo problem number 3 because I actually noticed an error in the formula when I worked it out. Not actually in the formula itself, but in what I typed up as to its meaning. So it's corrected now if you go back and you actually look in download. So A is equal to P times 1 plus R divided by N raised to the NT. That's the total amount plus your compound interest. In other words, how much money, total money, is in your account after T years. So when you multiply it by P, that's going to give you your total amount. So I changed that. That's a small change. And really this particular formula right here, we will encounter in some detail in college algebra. So notice I'm just going to say simplify the problem. It requires a calculator to solve. So we're going to use the formula. The total amount you have in your account is equal to your principal investment times 1 plus your interest rate divided by the total number of times compounded per year times that total number of times per year times the total number of years. So R is going to be our interest rate, and N is going to be number of times compounded. So basically, let's reread the formula, the question. So Karen just received 10 grand $10,000. That's going to be her principal investment. And she's going to place all of the money in a savings account that pays 5% interest compounded quarterly. So R is our interest rate, and 5%, remember, is 5% per 100, which is equal to 1/20. And the number of times it's compounded yearly is 4, so that's our in value. And she invested it for a total number of years is equal to 3. So all I want you to do is to set this up and to simplify. So the first thing we're going to do is just replace the values with the variables with their values. So P is 10,000. R is 1/20. And that's divided by N, which is 4. And N again, that's N up there, that's 4, and T is 3. So now all we're going to do is just simplify. So the first thing I'm going to do is just simplify the exponent. So this is the base. What is in parentheses is the base to our exponent. So A is equal to 10,000 over 1 plus 1/20 divided by 4 raised to the 12th. So now I want to simplify what's in parentheses. That's the base. And the first thing I want to simplify is what is 1/20 divided by 4. Well, another way to write that is 1/20 divided by 4. Now I'm going to write 4 is 4 divided by 1. And the way I can do this is I can change the division sign into a multiplication sign, but the price I have to pay is I have to switch the place of the 4 and the 1. The denominator becomes the numerator, and the numerator becomes the denominator. So that's the same as 1/80, 1/80. Now all of this is going to be raised to the 12th power. So our last simplification, because as stated, this requires a calculator, and you can grab your calculator and do it. I'm going to add 1 plus 180. 1 plus 180. Well, I need a common denominator. I can write 1 as 1/1, but the easiest way to do is to write 1 is 80 divided by 80. 80 divided by 80 is clearly 1, and I'm going to add 1/80 to it. Now that I have a common denominator, all I have to do is add the numerators. I get 81. So that's 81/80 times 12. And when you calculate this out and use a calculator, 81 divided by 80 I think is 0.125. I'm not sure where the decimal is. I don't remember. You raise it to 12, but as it turns out, she has a total in her account of $11,607.05. So if her original was 10,000, then you can see how much she earned in interest. She earned $1,607.50 just for investing it at a high rate of interest, 3%. I doubt you're going to get that anywhere for 3 years. Now you see how having money allows you to make more money. Whether it's fair or not is another question for another class, not this one. Let's look at one last problem. The fastest average speed by a cyclist across the continental USA is 15.4 miles per hour by Pete Penseres. If he traveled a total distance of about 3,107.5 miles at this speed, find his time cycling. So this is just the formula we were given. Distance, d, is equal to rate times time. So d is our distance, r is our rate, which is speed, our rate of travel, and t is our time. So we're asked how long, so we want to solve this formula for t, because we want to find his time cycling. So t is our unknown, so all we're going to do is divide both sides by r. And we're going to get distance divided by r is equal to t. And his distance was 3,107.5 miles, and his speed was, average speed, was 15.4 miles per hour. So when I calculate this, it turns out to be 201.8, and those are hours. And of course, if you can say, okay, is it humanly possible to bike for 12 hours a day? Well, let's just pretend that it is. Whether it is or not, I don't know. If that's so, and he actually biked 12 hours a day and slept 12 hours, ate and all the other stuff, it would have taken him about 17 days to travel all the way across the United States. So that's it for this lecture. If you have questions, just hit me up on Teams.